gotta keep them separated.
Hi guys, Mr. Brown here. I'm going to show you guys some separation techniques. Some of these are going to be using chemical changes or chemical reactions. Some are going to be using physical ones. So we're going to start off here with something called a Hoffman apparatus. All right, so Hoffman apparatus is used to separate water molecules into hydrogen molecules and oxygen molecules by using something called electrolysis of water. All right, so let me show you what this looks like here. All right, so here we go. This is the Hoffman apparatus, and what we have here, if we look close, there's a container right here with water in it, and it goes down a tube like this, and this tube connects to a glass cross section here and fills this side with water and this side with water. And so this thing is completely filled with water from top. All right, so what I have over here, this is a DC power supply. All right, direct current power supply, which means it's got a positive end and a negative end to it. And I have that hooked up using the wires. If I look here, the red end is going to be the positive end, the black end is the negative end. And so when I turn on the electricity, I haven't done that yet, what we should see is bubbles coming from those electrodes. So let's crank this thing up here. And hopefully you guys can see that, but from this electrode, I can see little tiny bubbles coming up from it. From this one, I can see little tiny bubbles coming up from it. And those bubbles are going to collect in the top of this. And so we will just compare how much we have, how much hydrogen, how much oxygen we're collecting at the top. So we're gonna have to come back and look at that. We gotta need to let that run for a little while. All right. So now what we're gonna do is we're gonna come over here. And this machine is a centrifuge. All right, a centrifuge separates things based on their density. And so what I'm going to do is I'm going to open up the lid on here and I'm going to show you what's in here. This is a pretty heavy metal rotating piece here, and inside I can put different test tubes in there. And so when I spin this thing, what it'll do is it'll spin around really fast. And if you've ever been on a carnival ride where you spin really fast and they drop the floor out from underneath you, that's kind of basically what this thing is. So what I'm going to do is we're going to go over here. This one is sodium chloride, and this one is silver nitrate. Silver nitrate's slightly toxic. It stains the bottle black, and that's why it looks like it does there. And so what I'm going to do, and this is an indicator to see if there's chlorine or fluorine or iodine. So we're going to set this aside here for a minute. And what I'm going to do is I'm going to put a little bit of sodium chloride, that's table salt solution, in this small test tube here. All right, so I'm going to put just a little bit in there. So it's just about that full. All right, I'm about a centimeter from the top of this. And now what I'm going to do is I'm going to put just a couple of drops of silver nitrate in there. So when I put the silver nitrate in there, I hope you guys can see this, okay? I get a white solid is forming in here. That's called a precipitate. I'm going to put in 3 drops, and then I'm going to set that to the side like that. Now, I've got this mixture here. How would I get that separated if I wanted to? Well, what I'm going to do is I'm going to put that in the centrifuge, but before I do that, I need another test tube to balance it with. It's got about the same amount of water in it. So I'm going to put about the same amount of water in this one as I have in the other one. And that's pretty close. All right. So then I'm going to set that down, and I'm going to go over here to my centrifuge, and I'm going to take the top off of it like this, set that down the side, and in hole number 1 on my centrifuge, I'm going to put a test tube in there, and straight across from it, I'm going to put another test tube to balance it off. All right. If they don't balance, this thing may, as it's spinning around really fast, it may become so erratic it might fall off the edge of the table. We don't want that to happen. So now I'm going to put the top back, or I'm going to put the lid down here. All right, and I'm going to turn this thing on so it starts to spin. So right now it's rotating. And let it get up to speed. Okay, still spinning, still spinning. All right, I'm gonna let it shut off here. I'm gonna let it finish moving. Okay, it just stopped moving, so I can open up the lid now on this thing again. And now, if I look at my test tubes, I don't know if you guys can see that, but that solid has gone sank all the way to the bottom, all right? And so I separated the solid from the liquid by spinning it really fast like that. So the more dense solid goes to the bottom. Now there's a little bit sticky here on the side of this. If I spun it some more, I could get that completely separated. But I think you guys get the idea. All right, I'm going to set those down, and I'm done with that. Now let's go over to here. All right, we're going to use some filtering here. So I'm going to set this down, and hopefully you guys can see what I'm going to do here. All right, here I have two compounds. This one is lead nitrate, and I'm going to put a little bit into my first beaker here. So that's lead nitrate, and I'm going to set this right behind it so I can remember that's what it is. And this one is potassium iodide. Now, iodine usually gives it kind of a yellowish color to it, so I'm going to put a little bit in there. It might have a little bit of a yellowish color to it. Okay, so here, what I'm going to do is I'm going to pour the lead nitrate into the potassium iodide and watch what happens. As soon as I pour it in, it gets yellow, it gets cloudy, and what I have there is a solid that's in there. If I want to separate that solid from the liquid, I'm going to do something called filtration, right? And to that, I need a funnel, and I need a piece of filter paper. So I'm going to set this down. I'm going to show you how to fold the filter paper. All right, the filter paper is a round paper. It is made so it's got little tiny holes in it, and kind of like a coffee filter will. And I'm going to fold that in half. But I don't crease it, because if I crease it hard, I might break some of the fibers in there. And I'm going to fold it in half again. And so if I look at, when I fold it in a fourth like that, I have 1, 2, 3, 4 layers. I'm going to open this up so I have 3 layers, 1, 2, 3 on one side and 1 on the other. And I'm going to stick this into the funnel like this. Now, if I look at the funnel kind of pops out. And so what I'm going to do is I want that thing to stick in there, so I'm going to use just a little bit of water. So I pour a little bit of water in here like this, and it sticks right where it's supposed to. All right. Now, what I'm going to do is I'm going to use this squirt bottle to pour this and get as much of this yellow stuff in here as I can. All right, hopefully you guys can see that okay. I think so. And so now I'm going to squirt that into there. So, and I just pour it in. And when I do that, I get pretty much all of the yellow solid out of that, and it's in there. Gravity is going to pull down the water, but as you're going to see, the little yellow particles, they get stuck in the filter paper. Those particles are too big. They're physically too big to get through the filter paper, where the water molecules are smaller, and they're going to get through there. All right, so we're going to leave that sit and drip for a while. We'll come back and look at that. All right, let's go over here and let's look at our electrolysis again. And if I look at the top, I've got a little tiny amount. I'm going to crank up the voltage on this a little bit, and I'm getting some gas on this side. I'm getting more on this side. All right, so if I look on this side, I'm getting more gas. I'm getting gas bubbles on here, but here on this side, I've got twice as much. I don't know how well you guys can see this, but this one is barely to there, so I've got that much gas in it. This one's got much more gas in it, and that kind of gives me a clue as to which one it is. All right, we're going to come back to that, and I'm going to turn up the voltage a little bit more here and see if we can't get some more. All right, this last part over here, the last one, is we're going to use distillation. All right, so distillation, let's look at this thing that we have here. Here I have a flask. This is called a bent arm flask. There is this flask in here. In the top of this thing, I'm going to put a stopper in it that has a thermometer. I need to know what the temperature is. All right, this bent arm flask, like this. This is what it looks like by itself. And I have a stopper here on this bent arm flask. So standing by itself, here is this bent arm flask. There's nothing in it right now. All right, so what I'm going to do is I'm going to put a mixture of alcohol and water and some food coloring in it. Right, in this side over here, this is called a condenser here. So what I'm going to do is I'm going to hook this thing up to the sink. Watch what I'm doing here. I'm going to hook that up to the sink like this. All right, and I'm going to turn it on very slowly. And if I look over here, I can see that this thing is filling up from the bottom, and it's going over here, and it's going to be pushed out of here. It's going to go down this tube, and I'm going to get water pouring into the sink over here. That's about right. And so now what's going to happen is cold water is coming up here, it's coming through here, it's going out and going back into the sink. What that is going to do is it's going to cool off any kind of gas that goes in here. So I'm going to connect this thing up like this. Whoops, connect that up like that, and then flowing out of this end, I'm going to have an Erlenmeyer flask to catch any drips that come out of this end. All right, so now what I need to do is I need to put some of my mixture in here. Okay, I'm going to stop this for just a second. All right, so while I had that off, what I did is I put a mixture of, there's water and green food coloring and some alcohol, specifically ethanol in here. And right now, the room temperature in here is about 20 degrees. And so cold water is going through here, and as I heat this up, what's going to happen is, since it can't go out of the top, there can't be any gas, any gas has to go down here, it's going to get cooled off, and we're going to condense it back into a liquid, and we're going to catch it in this Erlenmeyer flask. All right, so I need to turn on a heat source. All right, so there's a heat source, and what I'm going to do is I'm going to start heating this mixture up. And it should start to bubble here. And while that thing is heating up, let's go back and look over here at our filtration. Okay, I look down here at the bottom, and this is the filtrate. This is the liquid at the bottom. It's completely clear. There is no yellow solid in there whatsoever, because all of the yellow solid was trapped in there. So I separated that yellow solid from the clear liquid, even when it looked like it was too difficult to mix. Let's look at our electrolysis over here. All right, things are going well. Over here I see that this gas is down. I got about half as much as I have over here in this one. So I'm going to let that run for a while yet. And let's go back over here and let's watch our distillation. All right, now included in this liquid, I don't know if you can see, but I put some little tiny glass beads in there, and those glass beads help distribute the heat, and so it doesn't overheat too much. And so we're going to heat this up, and we should start to see the temperature going up, and the temperature went from 22, it's already at 27. So we're going to continue to heat this up. All right, the temperature now is above 30. And we'll see it in a couple minutes here. It should peak up here to about 50. We don't expect to see anything interesting until the liquid actually starts to boil. Okay, now I can hear that those glass beads are starting to move a little bit, and that means things are starting to get kind of hot. We're going to start to get some boiling here. And if I look at this, in here, it's starting to boil. I don't know if you guys can hear those little glass beads, but the hot vapor is going to come up through here. It's going to heat up this thermometer. If I get up here, the temperature is up close to 50 degrees, it's going to flow, the hot vapor is going to flow down here. It's going to hit the cold sides of this water, because there's a glass tube that goes right through the middle of that cold water jacket, and I should be getting something out of that end pretty quick. It's starting to boil pretty good. Temperature is now at 67. It's getting hotter and hotter and hotter, starting to boil a little bit faster. I might want to slow that down just a little bit, and I'm going to do that by pulling this away a little bit. Temperature is now at 74 degrees, and if I look over here, uh-oh, things are starting to drip out of this end. That means some of the vapor is cooling off, and it's coming out down here in this end from this. All right, something that boils close to 80 degrees, because that's about what it's at now. And so it's starting to drip pretty good right there, and it's right around 80 degrees. So something is boiling at 80 degrees in here. I can see that's boiling pretty good. It's going up the tube, it goes down through the cold water, and it condenses back into a liquid, and it's dripping pretty good here. All right, so, and that's happening right at about 80 degrees, and it's boiling, and the temperature is kind of stopped right at 80. It's not getting much hotter than that. Now it's coming out of here pretty quick. All right, so that was 80 degrees. I'm going to stop the heat on this thing, because we should be able to see what's coming out of there. And we're going to let this cool off a little bit. I just shut off the heat. All right, so we're going to do a little test here. I'm going to light the Bunsen burner again, but not to make it more alcohol. Okay. All right, so here I have a burning wood splint, and I'm going to put just a little puddle of water down here like this, and I'm going to try to light this puddle of water with the wood splint, and it just goes out. All right, now let's do the same thing. I'm going to pour a little bit of this liquid that we collected. I'm going to pour that onto the table. So there's a little puddle of the liquid that we have. I'm going to light my wood splint, and watch what happens here. If you look, that is burning now. What we have is alcohol. That's the ethanol that's out of there. And so the mixture of water and alcohol wouldn't burn. Water doesn't burn. So we have purified the alcohol pretty well using this distillation apparatus. And we use this because we know that water boils at 100 degrees. The alcohol, as it turns out, boils at 80. So when we were boiling this, the first thing that boiled was the alcohol. The alcohol boiled up here, the water stayed in there. The alcohol came down this tube, cooled off to lower than 80 degrees, and came out as a liquid down here. All right, so that's distillation. That's how that works. All right, so let's talk about this distillation thing again. Here is a very crude picture of, there's my bent arm flask. In there is a mixture of alcohol and water. Alcohol, as it turns out, boils at about 80 degrees. Water boils at about 100 degrees. Those two things are thoroughly mixed, difficult to separate. They're both clear, both colorless, all right? And in the top of this flask, I have it stoppered, and there's a thermometer in there, all right? And I watch the thermometer because that's going to tell me what's coming out of the end. As this heats up and this stuff starts to boil, vapors come up here. They can't get out through the top, so they're going to come down through here. This cold water jacket is just, the cold water surrounds the hot vapor that's come through here. Okay, it's not connected in any way. The water, cold water, can't mix with any of the vapors in there. We have cold water coming in here. It's cooling off whatever contents are in that tube, and the cold water is leaving out the top. And as this cools off, what happens is the alcohol is going to start to drip out of the end of this. All right, and we ended up with alcohol. We ended up with alcohol in the bottom of this. All right, so once again, the alcohol and water were heated by the Bunsen burner. When it got up to 80 degrees Celsius, all right, when it got up to 80 degrees Celsius, it was actually the alcohol that was boiling. Water isn't boiling yet. So the only thing is we're getting alcohol vapors up here. It cools off, as it goes through here, it turns back into a liquid and it drips into here, and this is where we got our alcohol. All right, so we've had this running for a while here, and I don't know if you can see how well you can see this, but on this side, with the positive electrodes coming up here, I have about half as much gas as I have coming up here on this side. There's about twice as much. Now, if I look at the equation for this, 2 water molecules, they're in here on the electrodes, are splitting into 1 molecule of oxygen and 2 molecules of hydrogen gas. That's why we have twice as much. So now what I'm going to do is I'm going to shut off the electricity here. And so the reaction is going to stop. And I got this gas collected at the top. Now, if I can trap this gas, what I'm going to do is I'm going to take a test tube here, and I'm going to put the test tube in here, and I'm going to open up that valve, and all the gas is going to be pushed into the top of the end of this test tube. And then I'm going to take it, I'm going to put this gas over here, and I'm going to mix that one with it. And then what I'm going to do is I'm going to put a burning wood splint in it. So let me collect the gas here real quick. All right, so in this test tube that I have here, I have my thumb over there, I should have a mixture of hydrogen gas and oxygen gas. And those two things together should cause a reaction. So I use the electricity here to split the oxygen from the hydrogen in the water. Now I'm going to put it back together. So here I have a burning wood splint, and over here I have my gas, so I'm going to put that in there. And there was an explosion that happened as the hydrogen and oxygen burned together. You guys heard that chirping sound. That was the hydrogen and oxygen. And if I look at this test tube, it's all cloudy. That's water vapor that's in there from the burning of the hydrogen and oxygen together.